If you don't understand, let me know. Okay, I just do it directly, because you take the derivative this one, you put the negative sign parentheses, and you take derivative this one, you still have the cos. That's why I have cos. And you take the derivative this one, you have negative sign, and negative sign is positive, and you keep the t. Okay, and the next one you have this one, you have a negative sign t, and the next one you have plus sign t, and the next one you have t cos t. Okay, the derivative now is here. Now the next one, okay, let me cancel out something. Let me cancel out the cosine and the sine and cos. So you'll have 2t, the cos will cancel out, the sine here will cancel out, and then we can have t sine t, and the other one we can have t cos t. Okay, for t greater to 0. So the next one, let's take the link. The link for the vector, for the derivative of the vector function, if you take the link, so we have to take the square root for this, and the square root is just this one square. You have 4t square plus t square sine t square plus t square cosine t square. Okay, so we have this one. So if you take the square root for this one, we have, if we factorize by t square, we have sine square plus cos square is just 1. 1 times t square is just t square. You will have 4t square plus t square. Okay, everybody got that one? Hopefully. So you will have this one, and you will have square root of 4 plus 1 is 5t square, and here you will have r prime. The link is, I advise you to leave it like this. Okay, let me move the t outside, since this one is already given. Let me point out something. Since this one is given, since t is strictly positive, it will help us. Check here. You have absolute value of t, square root of 5, and since t is strictly positive, then we can just write down the derivative of the vector function. It's just t square root of 5. That's it. Okay, good. So now we have this one. Now we can find the unit tangent vector. The unit tangent vector for 8. Let me write down here 8. The unit tangent vector 8 is just 1 over t square root of 5 of the vector function. And the vector function here is already given. No, the derivative of the vector function, by the way. And the derivative of the vector function is this one. Is the one we get here. Okay? And then we can write it down just as a 2t sine of t cosine of t, and that's it. Okay, this is the unit tangent vector. The unit tangent vector is that expression, and that's it for now. And then the next one, they ask you to find the n. Okay, the n is called the unit normal vector. The unit normal vector If you check also on the textbook, the formula for the normal vector is the derivative of the unit tangent vector divided by the length of the derivative of the unit tangent vector. That's the formula. Always write down the formula first before you move. Okay? Write down the formula first before you move on. Okay, now you have this one. Let's find the normal vector now. The normal vector is, we have to take the derivative, this one. We can still put this one inside. I think it's it will be very helpful, or we can just factorize. Let's factorize t. Let's move t outside and the t will cancel out. I think it will be very helpful. I just saw it. If you factorize by t here, the t will cancel out, and I will have just 1 over square root of 5, and the vector function is 2 here, and I will have the sine t, and I will have the cosine of t. That's it. Okay? So now the normal unit vector is just the derivative of the unit tangent vector divided by the length of the derivative of the unit tangent vector. That's all. Okay, now take the derivative for the unit tangent vector. If you take the derivative for the unit tangent vector, we will have the derivative for this one. We will have 1 over square root of 5. Derivative for the first one, we will have 0. Derivative for this one, remember the derivative of the unit, not the derivative for a vector function is the derivative of his component. Okay, so this one is 0, and this one, since it's sine, the derivative is cos t, and here is negative sine t. Okay, now let's take the link. The link for this one, the link for the unit tangent vector, you have to take the square root everything of 1. Let's put this one inside. Nothing will change. It's fine. It won't harm. We can just move it outside. Okay, let's move it here. We have 1 over square root of 5, everything square, and you can just say parentheses here is 0, and you can say square root for this one plus cosine of t square plus sine of sine t square. Okay, so now we have this one. This one is 1. 1 plus 0 is just 1. 1 times this one is just 1 over square root of 5. You know, square root of 5 is just, this one is just, okay, let me write down here. It's just 1 over square root of 5, everything square. We'll end up having this one because this one is just 1. And we can end up having this one, and this one is just 1 over square root of 5. Okay, yep, that's it. And then the normal unit vector is just 1 over square root of 5 of the unit tangent vector, and the unit tangent vector is this one, the expression on the top, and you can have 1 over square root of 5 parentheses, and then take the vector function is 2 sine of t cos t. Okay, it's here. It's this one. Okay, you can have it. This one is here. So now the normal unit tangent vector is 1/5 of 2 sine and cos t. That's it. You can leave it like that or you can move it inside. It doesn't matter. Okay, either way is good. Okay. Okay, next they ask you use the formula 9. Okay, B, I'm still working on number 18. Okay, still on number 18. Still on number 18. On page 860. Take a pause and look at it. Now for B, they ask you use the formula. Use the formula 9 to find the curve, to find the curvature, to find the curvature. Okay, number 9, the formula is on page, check page 856. If you open the book on page 866, on the bottom you will see the formula for the curvature, which is a kappa is the length of the derivative of the unit tangent vector, again is a length, divided by the length of the derivative of the unit vector. Okay, check it. That's the way you have to find it. So now we already know this one, we already know this one, and we know, let's go back. We already know or calculate the derivative of the tangent vector, which is here 1/5, 1/square root of 5, and the length for the derivative of the tangent vector of the vector function is equal to, I think we already done it, is equal to t square root of 5. Okay, t square root of 5. Okay, now we can have the curvature is 1/square root of 5 divided by t square root of 5. And then we can have here 1/t square root, everything square, and we can have just 1/t, 5t, just 5t. Okay, that's the curvature. That's it. Okay, now I finish question number 18. You should be able to do I want you to do question number 20 by your own. Do it. Working group and do question number 20.